Just a couple of housekeeping notes that I have repeated a few times now. Make sure you keep your camera and your microphone closed just to ensure we have a good, strong connection so that everybody can see Heather's presentation and video with clarity. If I see cameras coming on, I may shut them off just so you know what's going on. The presentation is going to last about 40 minutes and we will have 20 minutes at the end for questions. So if anybody does have a question, there is a chat feature in Zoom along the bottom of your screen. If you're on a desktop computer or a laptop, it may be across the top of your screen if you're on like an iPad or a smartphone. But there's a tab called chat. Just click on that, tap on that, and you can ask your question there. I'll be keeping an eye on it. If it's a time-sensitive question and there's a good chance for me to kind of interject, I may ask it to Heather right away, but for the most part, we'll do a bit of a discussion at the end. So you can also feel free to hold your questions to the end as well. We'll go till about 3 o'clock, but the call will stay live after that. So if we run a little bit long, we may be just a couple minutes over 3, but I'll try and keep it nice and timely. That is pretty much all that I have in the way of housekeeping. So I am going to introduce our speaker for today. So Dr. Heather Major is an associate professor in the Department of Biological Sciences at UNB, where her research focuses on the population ecology of seabirds nesting on Machias Seal Island, which is what we're here talking about today. Heather completed her PhD at Simon Fraser in 2011 on the recovery of ancient murrelets in Haida Gwaii, BC, and the Aleutian Islands in Alaska, following introduced predator removal. She briefly worked as a contract biologist doing environmental consulting in the Northwest Territories before moving home to New Brunswick in 2013 for her position at UNB. And today Heather is going to take us on a virtual trip to visit all of the lovely terns and puffins and birds that she works with. So welcome, Dr. Major.
Hi, thanks so much. And thanks to everyone who is here listening today. This is a really great turnout. So I'm really happy to see everyone here. So I'll kind of just jump into things. When I was putting this together, I really wanted the presentation to sort of go along the lines of what it is that our group is doing on the island. I know many of you have probably visited Machias before, been to the visitor blinds, seen the puffins and the razorbills, and probably gotten hit on the head by a tern or two. But it's not always very clear exactly what it is that the researchers that you might hear about are actually doing on the island. So I'm hoping to give you a little bit of insight into what it is that we're doing on the island, and also show you the island from the perspective that we get to see it from, given that we have a little bit more access to roam around and do the research that we're actually doing on Machias. And so I wanted to start just by thinking about, you know, other than the fact that all of us probably like to watch birds, why might we want to actually do research on seabirds? And the reason is that they are a top marine predator. And so seabirds themselves are really important and are used as an important indicator of the marine system. But of course, if you're to look for, here we go. If you're to look for a food web of the marine environment, seabirds often aren't included. And so this is one from the Encyclopedia Britannica. And you can see there's actually, whales are also not included. But seabirds are definitely not here. And so I'm taking the liberty to add them in. And the reason that I'm doing that is because, you know, for the marine environment, seabirds are actually very important. One, because they live above the water, and so do we. And so relatively speaking, they're then easier for us to monitor than other species are. In addition to that, they do eat things like small fish and also the plankton. And they also bring it back to colonies. So they congregate at colonies during their nesting season, where we as humans can go and monitor them. And we can look at things like what fish or what prey are they bringing back to those environments. And when we see changes in that, it often indicates that there's a change in the marine system. And so seabirds are that really key indicator of the marine system. And that's really what we're trying to do in the research we're doing at Machias Seal Island, is use them as an indicator of what's happening within the kind of greater Bay of Fundy, Gulf of Maine ecosystem. And so I'm guessing that everybody knows Machias Seal Island is located down here. It's a tiny little island kind of off the coast of Grand Manan or Maine. It is located in the gray zone, so both the US and Canada claim the island. And of course, there are two lighthouse keepers that live on the island year round. And that station is manned by the Canadian Coast Guard. In addition to that, the Migratory Bird Sanctuary on Machias Seal Island is regulated through Environment and Climate Change Canada, so also the Canadian government. And so that's sort of where a lot of our work kind of comes in, is monitoring those birds and seeing what's happening on the island. And so other than the birds, we also monitor a few other things. And a couple of things that I'm showing you right now, because they're gonna come up again and again as I go through some of the data that we collect for the birds, is sea surface temperature. So here we have sea surface temperature, and this is off the landing at the island. We go out every day at noon and drop a thermometer in the water. And so we can get a reading of how warm the ocean is around Machias Seal Island every day. You can see here the bottom is June and the top is July, and we have data from 1995 to 2019. So 2019 was actually our 25th year of consecutive data collection on the island. 2020 is a bit of a strange year because of COVID-19, as I'm sure all of you are well aware. And so our crew actually normally goes out in mid-May, early to mid-May. This year, they went out this past weekend. And so we've missed about half of our season already this year. And we won't have any data for June, unfortunately, this year. But we are lucky that we've been able to get it at all, because as a lot of you, or probably all of you know, there's a lot of studies and a lot of companies and everything else that haven't been able to open back up yet. So what we see is for both June and July on the top, mean sea surface temperature at the island has increased over the last 25 years. And then over here we have rainfall. The darker blue is June, the lighter blue is July, and this is total precipitation in millimeters, again, for our entire 25-year time series. And the interesting thing here is that up until there was a regime shift in the Gulf of Maine in 2006, and up until then, our mean rainfall amount on the island was about 121 millimeters. Since then, it's actually increased pretty dramatically to about 224 millimeters. And you can see, I'm going to point out in 2019, so last year, it was one of our biggest years. It was actually the second biggest year after 2006 for rainfall. And most of that rain fell in June, and it actually mostly fell during about a 2-week period when the terns were hatching. And what happened is that a lot of those tern chicks then died because of exposure, because of the rain. And so we don't have to think that rain is probably a really big deal for seabirds, because they live on the ocean, they have waterproof feathers, but it can cause reproductive it can cause reproductive success to fall and to not be as we would expect if we get too much rain in a particular year. So let's get back to birds though. So on the island, we have 6 focal species of birds. They include Atlantic Puffin, Razorbill, more recently common murre, Arctic tern, common tern, and Leach's storm petrel. So I don't have pictures for common tern and Leach's storm petrel. I tried to include only pictures that I myself have taken, and I don't have pictures of those myself. Common tern, there aren't very many on the island at present, and Leach's storm petrel, it's a very small colony, and they're kind of a recent addition to our focal seabird list. And so the terns obviously are a little bit of a special case, both Arctic and common tern, because they abandoned the island because of gull predation and disturbance in the early 2000s. And we've been working pretty hard to get them to come back to the island. In the last number of years, last 4 or 5 years, we've had quite a bit of success. We have more and more terns coming back to the island and breeding. And so it has been a bit of a success story until, of course, last year when we had the reproductive failure because of all the rain. And then this year, our crew wasn't there to to deter the gulls from disturbing and depredating the eggs and the eggs of the terns. And so when we arrived this past weekend, the crew informed me that there were no terns on the island. So I'm hoping that there will be terns next year, that they'll try to come back again, but it looks like the terns are going through another period where it's maybe going to be a little bit difficult for them at Machias. And today, because 6 seabirds is a lot of species to try to cover in 40 minutes, I decided to just really focus in on puffins and razorbills. And I'm doing this because they have they're a lot very similar in their biology. They're closely related species, but they're also different in a couple of key areas. And so that makes them interesting to compare with the different variables that we measure. So they are distributed throughout the North Atlantic. They're both cold adapted seabirds. So this means that they normally live in much colder places than Machias Seal Island. And actually, for both of them, the southernmost extent of their range occurs for nesting in the Gulf of Maine. In addition to that, they both lay just 1 egg each year. And so if that egg then, that reproductive event is not successful, they wait to try again until the next year. But they differ in a lot of traits for their juvenile life history. And so for puffins, we call them semi-precocial. And what this means is that the chicks are raised completely on land. So the parents bring food back to the island multiple times a day to feed the chick. And when the chick leaves the island at the end of the nesting season, they're independent of their parents. Razorbills, on the other hand, have what we call an intermediate life history strategy. And what this means is that the chicks are actually only raised on the island about halfway through their time as a chick. And at that about halfway mark, they leave the island with their male parent and they go to sea, and that male parent then feeds them and raises them the rest of the way on the ocean. So they're on land for much less time than the puffins are. And in addition to that, in terms of the Gulf of Maine populations of these 2 species, Atlantic puffins are thought to be relatively stable in terms of their population size. We did an ALCID census last summer, and our puffin population is about 8,500, I think it was 8,500 pairs. And that's relatively stable. It's about the same as it has been over the last 25 years. Obviously, in different years, it kind of goes up and down, but it sort of hasn't changed that much. For razorbills, they are increasing. So last year we had about 3,500 pairs breeding on the island. And this is up from about 800 about 10 or 15 years ago. So they're increasing and increasing relatively rapidly on Machias Seal Island. And so the first thing that we do, and one of the areas that we put most of our effort, especially early in the breeding season, is into banding. And if you've ever been to the island, you've likely seen birds that have these bands on them. And so we band birds because we can get a lot of information from looking at how those birds are returning. So you can get survival information over the lifetime of those birds. We also, when we capture them, we take morphometric measurements of all the individuals. And so then we have a record of the size of individuals over a 25-year time span. And our banding is then sort of coupled with resighting. And so resighting basically just means we sit in those blinds that the visitors go in, you guys have probably seen, or some of you, and we look out for birds that have bands on them, like this guy right here, or this razorbill. And when we see those, we then just zoom in and try to read the band numbers. And it's funny, I always think that, you know, people who come to the island as visitors are taking these really sort of beautiful pictures of all of the birds there. And a lot of the pictures that I come home with look like this because we're really interested in getting these band numbers. And so you can see here on this puffin, we have 2 different bands. So this one over here is called an alphanumeric band. And you can see this one is DS30. And so this is basically identifies this bird within the Gulf of Maine. And it's much easier to read because it's just 4 things to read, as opposed to this is the bird banding laboratory band. And this one has nine or 10 numbers, depending on the series we're using. And these numbers are a little bit more difficult to read, but these bird banding laboratory bands are the numbers are unique to individuals sort of throughout Canada. So, and the US too, and it might even be global, I'm not 100% sure. And so what we do is we spend a lot of time looking for these numbers, writing them down, and then we go back and enter them. And so every year we then know what birds have come back that have basically survived the winter and come back to MSI, and what ones haven't. And over time, you start to build a record of the number of birds that have come back, who maybe doesn't come back one year but comes back the next year. And you can use that to estimate survival. And we also band a lot of chicks, so we do have a lot of known age birds, so we can actually estimate age-specific survival at MSI. So there's a lot of really useful information in doing that. And I will just sort of put a plug in. If any of you have photographs that have bands on them where you can actually read the band numbers, either the alphanumeric or this one, we need actually more numbers than this. This isn't enough to identify that individual. You know, if you want to crop them just so we can just see their legs, we would love to have those records. We would need some information like the date, so including the year that you saw that bird, and where exactly you were on the island. So if you know what visitor blind, or could maybe like pick it out on a map, that could be really useful information for our database. The other thing we spend quite a bit of time doing is looking at reproductive success. And here what we're really doing is we're looking to see how the birds survive. And so the first thing we do, so down here, this is a tern egg that we found. So the terns tend to sort of plop their eggs on the ground. The puffins, this is an example of some of the puffin nesting holes. These stakes that you'll see on the island, these are permanently marked burrows. So you can see 2 here. And these would be marking puffin burrows that we actually monitor every year. So we go back to the same burrows, excuse me, every year, and monitor the reproductive success within those burrows every year. And we have marked burrows over the entire island. And what we're looking for here is, for every egg, how many of these eggs then turn into a chick? So that's our hatching success. And then how many of those chicks survive to then leave the island at the end of the breeding season? And that's our fledgling success. And together, hatching success and fledging success is your overall reproductive success. And so that's one of the other things that we try to monitor every year. And this is just some of that data. So this is productivity. So these are the number of eggs that then turned into a chick that left the island successfully at the end of the season. And so first we have puffins, and then razorbills are in the second graph. So if we just look at puffins first, you'll see, so I put a red line where this regime shift happened that I mentioned on the weather graph in 2006. And it's important because, as you can see, the reproductive success changed fairly drastically from before 2006. For puffins, it was about 65%, to after 2006, where it's now about 49%. And over time, it is still sort of decreasing. The other thing I think is really interesting and notable with this data is these large fluctuations in more recent years with Atlantic puffins, where you have these really, really good years followed by these really, really poor years for reproductive success. And these fluctuations, actually, for someone who studies population dynamics, are really quite concerning. And so if we then look at the razorbills, it tells a bit of the same story. The decrease isn't quite as big, and we don't see these really huge fluctuations kind of in more recent years that we did with the puffins. But before that 2006 regime shift, we had reproductive success at about 61%. And since then, now it is about 47%. So it has gone down just as it did for puffins. And then we also look at the timing. So basically when these things are happening. And I did mention that these are cold adapted species that are nesting at the sort of the southern extent of their range in the Gulf of Maine. The Gulf of Maine and the Bay of Fundy are actually warming very, very quickly. There are some studies that say that they're warming about 99 times faster, 99% faster than other bodies of water around the world. And so that's really concerning for these species that are cold adapted if we're getting warmer very quickly, because it should then quickly become not habitable for them, so not a great place for them to be. And so what we can see over a 25-year time span, so this is mean lay date, this is day of year, where about, so 130 is about May kind of 8th or 9th, depending if it's a leap year or not. So you can see that over time for puffins, they're laying later and later into the season. And one hypothesis that this could be happening is that they're not finding enough food to sort of make that egg as soon as they were before. And so you can see that the change that we've had is at, you know, about kind of 9 or 10 days up to 2 weeks in some years, different from early in our study to today. A razorbill, on the other hand, are doing the opposite. They're actually nesting now a little bit earlier than they were at the start of our time series. And so this is one of those things where I said that, you know, puffins and razorbills are interesting to compare because they are so similar, but then they also have these very different trends for some of these really important metrics of their biology. So the next thing that we do once those eggs become chicks, this time of year, we spend a lot of our time going around, excuse me, and measuring and banding those chicks. And so what this means is sort of going around, finding those chicks, measuring them, weighing them, and putting a band on them. And this way, when those birds come back as adults, we can then recapture them or recite them, and we'll know exactly how old they were, where they came from, and when they came from that location. So this is also really important information. And chick growth will also tell us, you know, whether or not those chicks are getting fed the things that they're supposed to be getting fed at the times that they need to be getting fed. So are they getting the quantity and the quality of food that they need to really keep themselves growing at a pace that is required for them to leave the island successfully? And so this is some of that chick growth data. So this is our growth rate per day for mass, and this is the blue one. And then over here, it's growth rate per day in wing chord, which is this green one. And I'll start with the puffins first again. So what we see, so we take a wing chord measurement, and that's basically a measurement of structural size. And so in humans, you'd probably use height, but for birds, we tend to use how long their wing chord is. And that's essentially kind of from maybe where your elbow might be to down to sort of the tip of their longest feather. And what we've seen for puffins is that they're now growing more slowly today than they were 25 years ago. And that actually corresponds with some of the data we have showing their size when they're leaving the island, and we're going to get to that in a minute. But they are actually leaving the island smaller today than they were 25 years ago. And this corresponds with a change in mass as well. The mass now, they're putting on weight more slowly than they were earlier on in our time series. Now, razorbills sort of follow the same kind of a trend for mass. So they're not growing in mass as quickly as they were 25 years ago, but their wing chord has basically stayed the same. So they're still growing their wing chord at about the same rate per day today as they were 25 years ago. And of course, the difference here too is that the puffins are staying on the island for a little bit longer than the razorbills are. But this data comes from what we call the linear phase of growth. And so basically, when seabirds are growing, the curve is sort of like an S. So they start out pretty slow, then they grow fast, and then they kind of level off and start to grow slowly again. And so this data just comes from that time in their growth when they're growing really, really fast. Okay, and so growth is then also fairly well related to the types of food that are coming into the island. And so one of the other things we do this time of year that's really important is measure, so quantify the type, the species, and the size of prey that are coming into the island each day. And so these are some graphs of the prey. This blue at the bottom is our excellent quality prey, and that's things like herring and sand lance. So those are the prey items that have the most energy per sort of unit of fish coming into the island. So those are the ones, when chicks are being fed those two species, they tend to do really well. The red ones are the moderate quality prey, and these are things like haddock and hake. And we see more and more kind of haddock and hake these years than we do kind of herring and sand lance. And then this lighter kind of color at the top is the poor quality prey. And the poor quality prey are things like larval fish, krill, other euphosids, that sort of thing. So things that, squid, that don't have a lot of energy density in them. So they're bringing them in because there's really nothing else in the ocean for them to bring into those chicks. And for puffins, one of the kind of troubling things that we see is the amount of high quality prey in the diet is decreasing fairly rapidly. And where we have many fewer of that kind of excellent quality prey coming in today as we did 25 years ago. And we have more and more of this poor quality prey coming in. Now, razorbills, we don't really see the same thing. So we do see more and more of this low quality prey or poor quality prey being brought back to the colony. And there is a decrease in the excellent quality prey that's coming in today than 25 years ago. But the drop is nowhere near as drastic as it is for puffins. And this is because they're finding their prey in slightly different locations to each other. So yeah, so it's interesting that they're going for, you know, roughly the same types of prey, but razorbills are still able to bring in a lot more herring now than Atlantic puffins are. And so one of the other really interesting things or data sources that we have at Machias Seal Island is related to the lighthouse. And we're one of the only locations that has a long-term roaming program that has this type of data. And this type of data that I'm talking about is measuring the chicks on the night that they're leaving the island. And so what happens for the puffins is that on the night that they leave the island, we think that the lighthouse, so basically when they leave the island, it's thought that they're sort of looking for the moon, and then they follow the moon out into the ocean. But because of the lighthouse, they get confused. And so instead of going to the ocean, they walk towards the lighthouse. And so they kind of congregate on the lawn that's in between the two houses and in front of the lighthouse on Machias Seal Island. And so our crew can then go out and collect the fledgers. We measure them, we band them, and then we send them out on their way to the ocean to come back hopefully in about 5 years. And so what we found, so this is a graph of body condition of these fledgers. And so body condition is very similar to like a body mass index in a human. And so we look at their wing chord, so that's that structural size and their mass, and it's kind of a ratio of that. And so at 0 is basically exactly the predicted mass is exactly what you would think it should be given how big they are. So given how big their wing chord is. Anything above 0 is an individual that is heavier than would be predicted for their wing chord. And so we call that good condition. And anything that's below 0 means that the individual is lighter than would be predicted for their structural size or their wing chord. And we consider those in poor condition. And so I'm going to put up this 2006 line where that regime shift happened. And what we see is that before then, you know, the average actual body condition index from 1995 until 2005 was about 8. So above that 0 line. So chicks were in general in fairly good condition when they were leaving the island. What we see after 2006 is that the average is almost always below that 0 line. And actually, if we average all these years together, the average body condition index is -18. And so the chicks are now leaving in what we would consider a more poor body condition than they were before. And that, of course, is worrying because it suggests that they're not getting the prey that they need, and it also might suggest that they could have lower survival into that adult stage, because that first year in the ocean is probably quite hard for them when they have to learn to find their own food and learn where it is they're supposed to go. And And so a lot of them don't survive that year anyway, but if they're starting out in poor condition, that is obviously quite concerning. And so I've just added in here the date of peak fledge for each year. And what we see is this sort of line suggests that the date that chicks are leaving the island has actually increased through time, so gotten a little bit later. But if we look at this axis, it's only a max 5 days different. And so I might suggest that it actually isn't all that different today than it was 25 years ago. And so that's kind of a lot of the general monitoring data that we do, a fairly quick look at it, really. And of course, we have these sorts of same types of data for common murres and for Arctic terns and for some common terns. But like I said, we don't have a lot of common terns nesting, so we don't have the same amount of data for them as we do these other species. And then we also have a number of graduate students who are working on the island. And so I thought I would just give a little sort of glimpse into some of the research projects that our graduate students do, in addition to just sort of the general monitoring that we do every year. And so Mark Barron was a master's student who he defended his thesis in November or December of this past year. And he was looking at the annual movements of Atlantic puffins. And so you can see in this picture right here, this is a geolocation tag. And so this tag uses light levels to give you an indication of where that individual was. So we attach these to individual birds that are breeding birds in burrows, leave them out for a year, and then you go back to that burrow the next year, and hopefully this bird has decided to nest in there again. So they generally do nest in the same breeding burrow year after year. We can take the geolocation tag off, download the data, and get positions for that individual over time. And so this is just an example of all of the birds that he tagged, kind of where they were located. And in general, what we see is that, when we're starting, kind of they're usually just mostly within the Gulf of Maine, Bay of Fundy. And then in the winter, they've kind of extended down the coast of the US to, almost to Cape Cod. And then by April, by springtime, they're coming back up towards Machias again. At the same time that was happening, we have another student named Mark Dodds, who is just finishing up his thesis right now. And he was doing something very similar, but with razorbills. And this project was a little bit bigger. We were collaborating with Environment and Climate Change Canada, and in particular, Dr. Rob Ronconi. And so we had collaborators put out tags on Biquet Island in Quebec, the Gannet Islands in Labrador, and then James Island and Gull Island in Newfoundland. And Mark put out tags on Machias Seal Island. And so let's just look at the Machias Seal Island data. So this blue, all the blue data in these graphs. And you can see over the course of the year, the razorbills actually tended to stay within the Gulf of Maine almost the entire year. And all of the other razorbills from the other colonies actually came down and joined them, but did end up going further down the US coast. And so we're able to now get some of this information on, we have all this information on what they're doing on the island, and now we're looking at what are they doing, where are they going during that time that they're not on the island. We also have some students that have just started or started recently. And so all three of these students are actually on the island right now. So Sarah Durham started a PhD in my lab in September of this past year, and she's doing some population modeling for puffins and razorbills, basically looking at their populations, what they're doing, how they've changed, and what is it that's driving those changes that we're seeing. So is it climate, is it food, is it, all of these things. Quinn Carvey, she started a master's in my lab also this past September. Tony Diamond, who was in charge of this research and I believe is on this call, has done quite a bit, has students do quite a bit of dispersal work using the band reciting records that we have. And so Quinn's project is basically taking those dispersal data and bringing it one step farther by looking at, okay, so we can understand sort of how they're choosing their island, where they're going to nest, where they're going to go, but does it change whether they're male or female? So that's sort of what she's looking into. And Tabitha Cormier just started a master's with me this past May, so just a couple months ago, looking at Atlantic puffin coloration. And so she actually did her honors thesis with me, and she came out to the island with me last summer for about 5 days. And we took a bunch of pictures of Atlantic puffins with a color card, and she was able to then use these to classify or quantify the color of different structures on the puffins. And so this is just some of her preliminary data. This year, her idea is to go back and kind of add more data to these samples to get and start to look at how color might relate to different metrics of their biology. So, for example, their body condition. So these are the different structures that she was looking at. And then here's some, so this is a color chart. So it's basically red, green down here, and then blue on the bottom. And so what this is, each of these points is an individual. And really the only thing that I want you to see is how much variation there is between individuals or among individuals within these different structures. And so the idea is that if color is different between individuals, that there's likely a reason for that. And is that reason, does that have to do with the food that they're eating or the condition that they're in or their reproductive output? So those are the types of questions that Tabitha will be looking at. And of course, there's other students. Tony Diamond still has one student left, and I shouldn't say still, but so Lauren Scopel is doing a PhD with Tony on the tern metapopulation within the Gulf of Maine. And let me see, I think that's about it for our current students right now. So I wanted to thank, first and foremost, Tony Diamond. So he was in charge of this research and is still a large part of the work that we're doing, and is still very highly involved in all of this work. The numerous field crews, so 25 years of field crews that have gone out and collected this data. Captain Andy Patterson and the Bold Coast Charter Company, so that's the tour operator out of Maine, and we often actually go out back and forth with him to the island. Captain Peter Wilcox and Sea-Watch Tours, so that's the tour operator out of Grand Manan, and he's actually who took us out this past summer or this past weekend. And they've provided lots of logistical support in other years as well. The Lightkeepers on MSI, and of course, Environment Climate Change Canada, and oops, I put the and in the wrong spot, and the Canadian Wildlife Service for all their support and help over the years. We get our funding from Environment Climate Change Canada, University of New Brunswick, NSERC, and we have had funding from the New Brunswick Wildlife Trust Fund. In particular, the New Brunswick Wildlife Trust Fund funded the Atlantic Puffin geolocation tag study in part. And then just before I end, before I take some questions, we do have a website if anyone wants to go and check out more. There's data on here, there's pictures on here, and also contact information. This year we started up a lab Twitter account, and actually the students on the island this summer are in charge of that account, and they are updating kind of live from the field what's happening with the birds on the island, so you can sort of follow along there and see what's happening on the island. And then if you wanted to contact me, this is my email address at UNB, and we also have kind of a general lab email address for more general inquiries. Yeah, so I'm happy to take any questions, and yeah, let us know and follow along with how the birds are doing this summer.
Well, Heather, thank you so much for sharing that. I've been at Nature NB coming up on a year now, and Machias Seal Island is definitely one aspect of conservation in our province that I've been really interested to learn more about. So it was really cool to hear about your work. And I mean, just every charming species of seabird seems to stop by there. So that makes it pretty appealing as well. We've had a couple questions come in during the presentation, so we'll start with those. If you have any other questions for Heather, you can drop them in the chat now. So the first question, Heather, came in from Jim Wilson. He was wondering if you could explain or elaborate more on this regime change that you mentioned that happened in 2006.
Yeah, so hi, Jim. Nice to virtually see you. I'm not going to elaborate too much on it because I am not an oceanographer and I wasn't here during that time. So the regime shift basically is what happened was the the ecosystem itself has sort of changed. So there's been a large change in the temperature of the water, in the species. So we now have a lot of, especially in the southern Gulf of Maine, there's a lot of new species, warmer water species that are present that haven't been present before. And I think there's also been changes in things like salinity that have happened. So it's basically the ecosystem kind of really shifted in that year to something that's just a little bit different than what it was before.
All right, thanks. Our next question comes from Todd Watts. Todd is wondering, what is the earliest known date for razorbills leaving with chicks?
Oh my goodness. The earliest known date, I don't know that off the top of my head. I could look back at our data and probably get an indication. And if I just flip back here to that, we can probably, these are lay dates, so that actually isn't going to help. I'm not sure. So they're leaving. So they're getting ready to leave right now. So they're generally leaving kind of in this early July timeframe. But I don't know what the earliest date is off the top of my head.
All right. Our next question comes from Lauren Clark.
Jump in there.
Oh yes, Tony, please join us.
I would guess, and I haven't looked at the numbers either, but it'd be about 10th of July. But most of them, it's mid to early 20s of July. But I'm sure a few have gone off about this time.
Yeah, so everybody listening, that of course was Tony Diamond speaking. Heather mentioned his work earlier in her presentation as well, but he is also one of the leading researchers on Machias Seal Island who has done a lot of research in previous years. Okay, our next question comes from Lauren Clark. What is the percentage of birds that have been banded that you actually see again?
So it's different for a chick than for an adult. And so when we band an adult, they generally usually come back to the island. And so survival rates usually are kind of, for a lot of these species, anywhere between, 85% to somewhere, up in the 90 percentile. And so we generally would see that, that percentage of birds coming back if they're banded as an adult. If they're banded as a chick, it's a little bit smaller because they don't necessarily come back to the island where they were hatched. And some of them are seen on other Gulf of Maine islands. And we actually work really closely with our partners at the National Audubon Society in Maine and the U.S. Fish and Wildlife Service, who do similar work to us on the Gulf of Maine islands. And actually we have one large database where we're all sort of sharing our data amongst us. And so it actually ends up being a really, really useful data set and a really good collaboration within the entire Gulf of Maine, including Machias Seal Island. So yeah, so the chicks are we don't usually see them for at least 3 years after they've been banded, and sometimes up to 5 to 7 years when they've actually recruited to an island and are about to start to breed. And so if they have, let's just assume that they have a survival rate that's about similar to an adult, so somewhere in, the 88% range, you're not going to see, and then you wait 5 years, you're probably going to see, maybe 60% of them, 70% of them, something like that at most.
All right, thanks, Heather. The next two questions that came in are pretty similar. They have to do with the fishing habits of razorbills versus the Atlantic puffin. So the first part of the question, why do you think razorbills are more successful at getting herring than puffins?
So razorbills are bigger than puffins, and they can also dive deeper. So they're probably just accessing a part of the water column that Atlantic puffins aren't able to access. And so it's probably all kind of related to exactly where within the water column they're looking for prey.
Okay, there was no name on that question, but the second question comes from Andrew, and you did answer it. He was wondering if razorbills can dive more deeply than puffins, and it would appear that yes. They do dive more deeply.
Could I jump in again?
Yes, absolutely, Tony. You're welcome anytime.
The interesting thing about diving depth is that razorbills can dive more deeply, but they don't. So our master student, Stephanie Simmons, studied this with GPS tags. And the diving depths of puffins were actually deeper than razorbills. So either puffins or razorbills haven't read the textbook about how deep you're supposed to dive, depending on how big you are as an acid. I mean, my honest answer to the question of why razorbills more successful at getting herring is I do not know. After 25 years, I don't know. But Heather's going to find out.
Okay, the next question comes from Robin. Does the dropping puffin population reflect a net loss, or are the puffins just going somewhere else?
No dropping.
So there is no drop in the puffin population. So when we look at the number of breeders, so the number of nesting pairs on the island, it's stable. So there really hasn't been a change over the last 25 years. And so even though we're seeing these a reduction in reproductive success, we're not seeing that play out in the population size yet. I would think that as time goes on, and if the warming that we've seen continues as we see it, that we could start to see a decline in the population, but we don't see that yet.
All right. The next question comes from Sam. Sam is wondering, how long do razorbill chicks stay with their fathers at sea before they become independent?
That's a great question, and I don't know the answer. One of the things that, we can make some assumptions based on how long most alcids stay before they gain independence from their parents. But, one of the kind of mysteries of seabirds is that once they leave the colony, we don't know a whole lot about what's happening after that. And Tony, if you want to jump in, if you have any indication of a better answer for that question, I know I'd love to hear it, and I'm sure that Sam would too.
No, I don't know either. That's a mystery that we're still stuck with.
Okay, another question from Louise Nichols. This is regarding the study on color. Is it possible that color could be related to reproductive choice?
Well, maybe. Yeah, that's one of the things that we would like to find out. Unfortunately, so that was actually one of the questions that Tabitha had wanted to ask in her master's. But unfortunately, because we only got out to they only got out to the island this past weekend, and most of the puffins are already on chicks, so most of the eggs have hatched. We can't really look at that. So Tony had a student a few years ago named Kevin Kelly, who did some color work, and he found that the color of the bill did change over the course of the season, so it gets more dull as the season progresses. And so we had really wanted to measure the color over the whole season and correlate that with reproductive success. But because of COVID-19, we were unable to ask that question this year. But no, that's a great question, and we don't know the answer.
Very interesting. That's the end of the questions that we have for now. I'll leave a couple more minutes for any others to trickle in, and I will ask a question, Heather. So what does the rest of the year look like for you? I mean, I know that our field season here at Nature NB is mostly back to normal with a few exceptions. So what does the rest of your field season look like?
Well, so the crew is out on the island until about mid-August, and right now they're just playing catch up. So we missed the early part of the season, so we won't have lay dates or hatch dates for our species. Right now, almost everything has chicks, and so we're sort of into that kind of measuring chicks to get to get their growth rate, and then also looking at the food that's coming into the island. So I actually was just contacted yesterday by some colleagues in Maine who are oceanographers, and apparently there's a warm water blob in the Gulf of Maine, and it looks like the Gulf of Maine could be in a heat wave similar to 2012, which was pretty devastating for our birds. But in that year, and that was a food thing, so the food kind of ran out by late July. Right now, it looks, you know, the crew's only been on the island for a couple of days, so it's hard to really say anything about what's happened so far. But right now, they told me that on their first kind of walk around the island, there was lots of chubby puffin chicks, so that's a really great sign. But if the food runs out, it could be a really hard year for them. So we kind of have to wait and see. Yeah. So basically, from now on, we're basically just trying to get caught up on some stuff and get as much data as we can out of this year.
Yeah, I feel like the idea of wait and see is kind of the theme for a lot of organizations at this point.
Yeah.
All right, well, we haven't received any other questions in the chat. Tony, do you have any closing thoughts you wanted to share with everybody?
Well, my main thought is how wonderful it is that Heather is taking this work over. When you start a long-term project like this, you worry for the last few years of it, well, is this going to end when I retire? So when Heather came along, I was absolutely delighted, and she's doing a fantastic job.
Thank you, Tony. I'm very happy to be doing this work.
Yeah. Yeah, and we were very happy to hear from you today, Heather. No more questions have come in, but there's a little bit of praise. Caroline says thank you. April says thank you. Susan says thank you. So yeah, I think the general sentiment from our audience is pretty clear. Heather, thank you so much for not only presenting us today, but for all the work that you do.
Yeah, and thanks everyone again for coming and asking those really thoughtful questions. This was really fun.
Yeah, as I mentioned at the top, this webinar was recorded, so I will be saving it and adding it to our YouTube channel in the next couple of days, and then that will be distributed for anybody, like I said, in your networks who maybe were not able to participate. So I'm going to end the webinar now, but thank you so much to everybody for coming, and thanks, Heather. It's been great.
Yep, thank you.
See ya. Bye, everybody.